Hi, welcome back to microwave engineering. Today I will review Smith chart. Last week we already have some information. We have some knowledge about the Smith chart, and also last week we already practiced how to what is Smith chart and how do we derive a Smith chart. Um, to to start on today's class, we will use the same as last week. We will use Zuvio to upload your answer to my question and show me you understand what you have learned. Okay, last week from the beginning, we have a structure about high frequency transmission line. This is what we started last week. We have a high frequency transmission line, and this transmission line has a length L. Please prepare your paper, then start to draw this picture again. Then I will start my question as the review, okay? And the same, I want you to upload your question, your answer, like last week. And you can also, you can change your answers. Okay. Basically, I try to use Ruvio to understand how much you can understand. Okay? Okay, if everyone is ready and you have a paper on your hand, you can start try to draw this picture. Okay, first, what do we have? We have a load which has the impedance ZL. When this load is terminated at the end of a high-frequency transmission line, and this high-frequency transmission line has the characteristic impedance Z0. The length is L, and the propagational constant is beta. Okay, this is the basic structure of how to derive the Smith chart. First, I want you to answer the question I've already showed you last week. At the point when L equals to 0, or you can say Z equals to 0. Z is the position, or you can say the length is 0. At this point, you can obtain what is your input impedance. Z in equals to what? When, or you can write down. Yes. Yeah, your answer is correct, but I want you to write it down on the paper. I want 4 answers, so don't worry. You just write down Z in 0 equal, this is the first answer, okay? You can draw this picture as well. And you write down Z in 0 equals 2, and this is first question. And what is gamma at 0. This is the second answer. Answer these two questions, okay, in what type? Using ZL and Z0. Okay, 1 and 2. These two questions are easy, but I want more. I want more. And more when at the position Z equals to minus L, or you can say it when this is a position L, the length of the transmission line L. At this point, what is the input impedance? This is the answer for the question number 3. And also, what is the reflection coefficient at the position or the length L? This is the answer for question number 4. Okay, we've already derived these equations. We've already introduced this. We already answered all of these 4 questions, but I want you to answer me these 4 questions again and upload the answer on the paper. For the question number 4, you should also write down 2 forms. For the number 4, okay, form number 1, you will use the answer we already get. We will use the notation Z in L. This is the answer from question number 3. And for another form of the question number 4, you are going to use the formation of the forward voltage and the backward voltage, and obtain the relationship from the question number 2. Okay, if you are not clear about my question, you are very welcome to just ask. Okay, you can raise your hand. You can just say that about your question. There are 4 questions you need to know at the beginning to derive the Smith chart, to derive our Smith chart. Okay? Okay, let me see your answer. So, Xie Boyi, you are the first one trying to answer my question. Your Z in.
No.我还没完成。
Okay. You should separate your Z in at different position, okay? Those are not equal. Okay, so let me repeat. You basically, you need 4 parts of the answer. But for number 4, there are 2 forms. Okay. For the first form is related to number 3. For the second form is related to number 2. So actually, you have 5 answers. Okay, let me see Lin Dinsen's question, the answer. So, yes, Lin Dinsen, your answer is perfect. You obtain a point. So, very good. And Peng Hao. Yes, Peng Hao, you are also correct. But Peng Hao, you need I want you to enhance your answers. Peng Hao, you there?
Yes.
Okay. So you already
第四
have
题还
the
没写第二个。
yes.
等一下。
You need to have this one, then you can. Yes. I am very happy that you understand what I'm talking about and that you give me the right answer. That is good. So, okay, 石凯生. Yeah, Su Kai-sen, you also need to give me more information about this, the blue one. Okay, Su Kai-sen?
Okay.
Okay, I hope you understand what I want. This is how we derive, but I think you are good enough to obtain the point. So I can give you a point first, but you need to complete.
好。
So for 资讯 yes, 资讯 you are correct. 修文
老师，我写错了，我再一下。
Okay. So 曹德宇 yes, 曹德宇 you are correct. 张玉信 yes. 张玉信 and 玉祥 and 玉祥 you also need to give me this one, the blue one.
好，我再看一下。
Okay, for this one. This blue one. And you will have an equation, right? For the phone 1 equals to the phone number 2, and this is the Smith chart. is the beginning of semester. Okay, 何心婷, you are correct. 何心婷. Okay. Boy, have you done?
Yes.
Okay. Boy.
老师黄秀文也好了。
好。谢博弈 is correct. So, how about others? 玉祥, you correct, right? Okay. How about 梁家凯 and Yo Jun? You want to try? And Yu Xiang, you need to correct your answer. Yu Xiang, do you want to try more? I already give you a point, but
我写一下，我应该知道是
okay. Yeah, show me what you've learned last week. How much you understand. Okay, this is Smith chart. Okay, you will use it again and again if you are trying to use the microwave engineering as your knowledge to earn the money. Okay, you will see Smith chart again and again. So it's worth it to spend some time to understand. Okay, Yang Jiakai, you are probably okay, but so what is Yang Jiakai? You guys can also, you're almost correct, but you can change this part to something, right? And you know the answer of minus j beta L divided by exponential j beta L to another form. Okay. For Liang Jiakai and Yu Xiang. Yes, Yu Xiang, you are correct. And Xu Fuyao. Also, Xu Fuyao, the same. Try to do this. So, okay, that's good. Oh, it's okay. It's okay. So, that's good that everyone already understand the beginning of the Smith chart. This is the answer. This is what we derived last week. Okay. So you try to have this equation. This is the equation for the Smith chart. This is for the answer in number 4 and in 2 different forms. Okay, you can, for this part, you know something. All of this is the reflection coefficient at the position L, right? Either the left part, also the right part, 2 of them are different forms of the reflection coefficient. And for the left part, you can see that this is also the input impedance. As I said, Smith chart is trying to give the relationship between ZL to reflection coefficient. This is the relationship. If you know what is the impedance at some point, And you also can obtain the reflection coefficient at this point. This is the Smith chart. But there are more assumptions. Okay, so second, I want you to give me these assumptions. Okay, write down the assumptions you try to do for this equation. Let me write down this equation again. But I want you to write down how many assumptions you can use to obtain the answer. Okay, let me write down this one first. Z in L minus Z0 divided by Z in L plus Z, okay? And I want you to write down all of the assumptions. What is assumption mean? Assumption means you need to set something equal something. Okay. You try to define, to simplify this question. How many? I think maybe 5. A lot. You set something equals something. Try to remind yourself. Okay. Then I will clean your answers and show me your answers again. What are the assumptions we used to understand how do you change these equations to Smith chart? What is the assumption? Or do you need more hint? What is the small cl? What is theta? Okay. And also, I remember there are more. And also, what is another form of ZL? And for this part, the gamma, all of them will equal something. I think 4. There are 4 assumptions. Show me your answer. And don't get too far, okay? It should be very simple. Those are simple questions, and you are supposed to just give me a simple answers. This is the definition. And for 3 and 4, I just try to separate the real and the imaginary part. You guys still thinking? because no one answered yet. This is the definition. For the first one, what is small zl? Write down the answer on your paper and take a picture again. Okay. Okay. Let's see, 谢博弈。
老师，那个1跟3可以再讲一次吗？
Okay. For the first one is the definition of small zl. Definition. How do you define this normalized zl, small zl? And then for the third one, you just separate the real and the imaginary part for 3 and 4. So Shebo, you are correct. Okay. Shebo, correct. I forgot to give you 许富瑶 and 梁家凯 the score. 谢博弈 Okay. And 张玉信 张玉信 for number 3 and the number 4 it's not an equation. You just assume the real and the imaginary part. Okay?
Okay.
Okay. So 何欣婷 Oh, please enlarge your answers to help me to read. 何欣婷 Yes. Okay. Your answer is correct as well. And 施凯森 Okay.施凯森, your notation is a little bit different from what I used last week. Maybe you can put a small L for number 3 for the real and the imaginary part for number 3.
Okay.
施凯森, I think you understand. So, also. And Huang Xiuwen, okay, for number 4, I want to separate like number 3 for the real and the imaginary part. Okay, Huang Xiuwen.
Okay.
Good. 林点胜 Yeah. 点胜 Okay. 许富瑶 for number 4 and the number 3, I want you only to separate the real and the imaginary part. And for the number 1, it is a definition of a small zl. Okay, 许富瑶 for number 1, it's not a definition. Okay.
所以是还要再改吗？
Yeah, you this is not my question.
Okay.
And Lin Youjun for number 3 and number 4, I want you to separate the imaginary part and the real part only. 曹德宇, your answer is correct. 曹德宇 Okay. 曹德宇 Okay. So, Xie Bo Yi. Okay. So who else? 张玉信, Hong Hao, Xu Fuyao, Yu Xiang. 梁家凯、黄修文。Okay. These assumptions are very important. If you are confused about these 4 definitions, you don't know how to use Smith chart. Okay? Those 2 are important. For the first question I ask you is, what can we use in Smith chart? It is the transformation between the impedance and the reflection coefficient at any point. Okay, this is the answer for the first question, and you give me all of you gave me the correct answers, and this is the chart. Okay, for the second one, the second question I ask you now, this is the definition, and this is important because this is how to read Smith chart. Okay. 谢博义 already correct. So 张玉信. Let me check Zhang Yuxin's answer. Yes, Zhang Yuxin, you are correct. Who else? He Xinting, correct. Shi Kaisen, correct. Chen Zixin, correct. And Huang Xiuwen. Huang Xiuwen, you still, for number 4, you didn't understand my question? Huang Xiuwen. Huang Xiuwen, you there?
哎，在
For number 4, you give me the equation, but I didn't want your equation. I want the assumption. Okay. For number 4, I just want you to separate the real and imaginary part, like number 3. Number 3 and number 4 are very similar. Okay, this is the answer.
OK，
3 and 4 similar. Yes, Xu Fuyao, you are correct. Xu Fuyao. Yes. And who else? Yes, Li Youjun.
老师，
Li
我
Youjun. Yeah. Who? Who are you? Who just speak? 邱玉祥. Cho Yuxiang, for number 3 and number 4, you still didn't get my point, okay? Number 3 and 4. Hong Hao, 3 and 4 just separate. You just assume what is the real part and what is the imaginary part, like what I did last week. Basically, this is not very difficult. This is just try to remind you what did we do last week. This is just a reminding. Yes. Huang Xiuwen, you are correct. And so far, Liang Jiakai, Peng Hao, and Chou Yuxiang. Do you still want to try, or you just want to answer?
I want to try.
Okay, please. We will not have many new information today. Okay, in today's class, we just try to use Smith chart. So if you have time, maybe you can print or find out your Smith chart that you're in your paper. You need 2 or 3 Smith chart, and you also need to prepare your compass, your 圆规, and your ruler. Okay, the 尺. And your probably pencil and the eraser. Yeah, Peng Hao, you're correct. Yes. Peng Hao. Okay, so Yuxiang and Liang Jiakai. Yuxiang. Jiakai. Yes, Yuxiang, you are correct.
Mm, 老师，我上传了。
Okay. Yeah, Yuxiang are correct. Liang Jiakai, I didn't see your answer.
我正在上传。
Hurry up. Okay, so let's see. So from the beginning, there is a transmission line connect to some load, ZL, okay? If this is ZL, Z0, and the characteristic impedance of the transmission line is Z0, and you will think about that. For example, this is a transmission line. The characteristic impedance is 15 ohm. Okay, you connect this transmission line to a load, which is, for example, 100 ohm. Okay, so what is ZL at L? For example, what is, let me clarify my question. What is Z in change to small zl if the position is 0? What's that? And what is your, for your answers, this is RL plus JXL, right? And what is RL? And what is XL? For this example, and I didn't tell you the total length of this transmission line. I just ask you these 3 questions at L equals 0. This is question number 1, question number 2, and question number 3. Please show me all the questions. And for these questions, I will give you just only 2 minutes. Only few people can give me the answer, okay? 2 minutes. So I will stop the question at 2:11. 2:11, okay? So you have 2 minutes to answer this question. You need to show me what is the answer for number 1, number 2, and number 3. I will just give you the answer, and I will only check who can get a score. Okay, not everyone can get score because this is a question, not just leading you to understand, because those are easy questions. You already answered this 4, so you are supposed to understand what is the situation for this one. Please give me 1, 2, 3. Okay, use this circle 1, 2, 3 to show me where is your answer. Okay, 1, 2, 3. One more minute. Please hurry up. For the number 1, number 2, number 3. What is the answer for number 1? What's the answer for number 2? And what's the answer? Please give me a circle. Please denote. 帮忙标个编号好不好？1、2、3。Okay, 5 more seconds. 5, 4, 3, 2, 1. Okay. Okay, let me stop. 史凯生，你还是没有标编号哎，还是
老师，我重来，但是最后5秒来不及传。
就一开始就跟你说要标编号了哈。来，我们真正答对的有谁哈？反正你不缺分数哈。谢博弈 ，you are correct. Also, give me answer. The answer is because ZL it is normalized. So your definition of ZL it is Z in at L and the Z 0. Okay, this is your answer. And the Z in at L, which is Z in, because it is at the length equals to 0, which is Z in, Z0, and equals to 100 over 50. So answer is 2. Okay, so the first question is 2, and the second and third question, you separate the real part and imaginary part. So the second one is 2 as well, and the third one is 0. So it is 2, 2, 0. Okay, 史凯生, I can give you just answer, but next time please hurry up and give me the right answer. Okay?
OK，
Please. Yes. It is easier for me to read. Okay, 史凯生 and 许富瑶, you forgot to divide by 50 ohm. And 知心, okay. 知心, you didn't just give me a number 1, 2, 3, but I can still give you point. And 博弈, okay, 林鼎胜, okay. And 何心婷, 江玉信. Okay, so so this is the starting point. If this is 200 more 100 ohm on and connect with 15 ohm high frequency transmission line, okay? So you will use the 2 as the starting point, and you will use RL equals to 2 and XL equals to 0 as your starting point. Okay, this is how we use the Smith chart. And when you have a transmission line L, you will change your circle. Just giving you some hint about how to use the Smith chart. There will be a circle. You will need to find out where is true. You will need to find out where is RL equal to and where is XL equal 0. And this is the center of the Smith chart. You will find out this point. Here. And the real part of the load has a real part 2. This is a normalized real part. And the imaginary part is 0 at this point. Okay. And when you have a length of transmission line, for example, if the transmission line, if this is a quarter wave transmission line, which means the L equals to lambda over 4. The answer, the impedance of the transmission line will transfer to another position. This is the quarter wave. Okay, from this one to this one, and this will be the new Z in L and 0. Okay, the L is lambda over 4. This is one of the example, and we will have more examples. Last week, we tried to explain. For this part, I just try to remind you what we are doing for those denotes. But last week, we only teach you about the real circle. This is what we learned last week, just only the real circle. Let's try to remind you some information about what we did last week, okay? This is the equation we try to understand for last week and this week. And your starting point, ZL, this is what you give me 2 and 0, right? This is what you did for this part. And this is the reflection coefficient at the position L. You can transfer this equation to this term. What you need to do, just multiply everything. You just reorganize this equation and you can obtain these new equations. And as you already give me the assumption, as your assumption, you separate the real part and the imaginary part of the ZL, and you obtain this this equation. And also for your reflection coefficient, you can also separate the real part and the imaginary part. Okay. And those are just, you just spend a lot of time to separate the real part and the imaginary part. You can finally obtain these two equations. For the blue one, it is the circle of the real normalized input impedance. And for the red one, it is also the circle of the imaginary part of the normalized impedance. And these two equations can also transfer to two circle equations. For the first real circle, this is what we call this the real circle. Remember, this is a normalized impedance real circle. This one is similar. You just change the notation to this equation. And this is what we learned last week. This circle is shifted to a new position. The center of this circle is shifted on the x-axis to some position, which is a over 1 plus a. And for the circle, for this real circle, all of the y position is always 0. So all of these real circles are on the center, the axis of the center. And because of the radius of these circles is always 1 over 1 plus a, which means the position of all of the circle, the left part of the position, it is always on 1. Okay? Because a over 1 plus a plus 1 over 1 plus a is always equals to 1. So this is always 1. This is always 1. So you can obtain all of the real circles will look like these pictures. Okay. Before we go to take a break, I want you to give me, I want you to see your Smith chart. Everyone to check your Smith chart. Okay. You can see that on Smith chart, there are a lot of real circles. I use the blue one. Can you see the picture clearly? Every of the circle, all the circles you connect to 1. This is 1. This is x equal 1. Every circle, you can see every circle is connected to this part. And you can read every number. All of this number means your gamma L equals to this number. I'm sorry, not correct. Your RL RL equals to this number. Okay? This is RL equals to 0.1 circle and 0.2, 0.3 for all of them. Okay. Those are all the RL. So for this circle, you can read the number 1.0 means on this circle, on this blue circle, ZL at the length L over Z0 equals to 1. If the transmission line is 50 ohm, all of ZL on here, it is 50 ohm. Okay. Let's take a break and I will give you more information later. Okay, let's take a break.